Welcome back.
Hi, everybody. What about tangent?
Do I get to go
What
now?
about tangent? You get to talk, Mr. Like
Tangent. I love tangent.
What about tangent? I hate tangent. No, I'm kidding.
We talked about tangent earlier in the previous part of the lessons. Tangent was sine.
Oh, I remember. Sine or
divided by
cosine?
cosine, yes?
Okay.
Now, if I have a function written as a fraction, what happens when the bottom is 0?
Oh, you can't do that. You can't divide by 0.
You can't divide by 0. And on a graph paper, what happens when you have that bottom number to be 0?
Isn't that a vertical asymptote?
Yep. So
Oh, it's a vertical asymptote.
whenever cosine of x happens to equal 0, we get vertical asymptotes. How do you spell vertical?
That's right. A-S-Y-M-P-T-O-T-E-S.
I can spell asymptote.
Oh.
I can't spell vertical. All right. So what's going to happen for a tangent function is we have to kind of look at what's going on here. But our cosine value, whenever it was 0, which if we remember our cosine function,
Oh, yeah.
was 0 at pi over 2,
And 3 pi over 2.
3 pi over 2. And if we kept going, it's going to be negative pi over 2, and then negative 3 pi over 2, and then 5 pi over 2. And
So all the odds.
all the odd numbers of pi over 2. How's that?
That's great.
7 pi over 2, 9 pi
So-
over 2. I can do this all day.
All of those are going to be asymptotes?
All of these are going to give me vertical asymptotes
That's
on
a
my
lot of asymptotes.
tangent function. Yes, it is.
Do you have to draw all those asymptotes?
Hopefully not all of them,
Oh,
just
good.
2 of them.
Okay, good.
Okay, so let's look at what a tangent function looks like.
Very nice.
Here's a tangent function. As you can see, at pi over 2, these graphs don't match, so we're going to end up with a vertical asymptote at pi over 2, another vertical asymptote at negative pi over 2,
And another one at 3 pi over 2, which
another
is
one
off
at
our
3
screen.
pi over 2, and if we kept going with this graph, this would go
Right there.
3 pi over 2, we'd have another one,
Okay.
and this graph would just go up like that.
Okay.
All right, so between the asymptotes, what's the y, or what's the y value of this tangent function?
The y value is 0.
0.
Right in the middle?
Right in the middle.
Oh, okay.
So
That's an
right in
intercept.
the middle of the two
Asymptotes.
asymptotes is 0. Does that work for the next one?
Yes.
Perfect.
Okay.
So we've been used to breaking things into little, like fourths, right?
Right.
So we have this distance between the asymptotes. We break it in half and we get a 0.
Okay.
What if we break it in half again?
Well, that's pi over 4.
This is pi over 4, and pi over 4 was a 45-degree angle.
Oh, the tangent of that is 1.
Tangent was 1, so there's a point right there.
Okay.
And then if we go to the other side, negative pi over 4, that would just be a tangent of a 45-degree angle in quadrant 4.
So
going
that's
down.
negative.
So it's negative 1, because tangent is not positive in quadrant 4.
Correct.
And what we have here, unlike, just like sine and cosine had 5 points, we have 3 points and 2 asymptotes.
So that counts as 5 things.
5 things.
Okay.
And you notice that's all we need, because a tangent function starts like this, and then starts to repeat itself.
So it is periodic.
So it's periodic, and what is this one period of our tangent function?
Well, it's a positive half a pi and a negative half a pi. That's a pi.
That's a whole pi.
1 whole pi.
So the period of a tangent function is pi,
Oh, okay.
not 2 pi. Sine and cosine were both 2 pi. They had to go all the way around the unit circle before they repeated themselves. Tangent, if you remember, was all, what was it?
Students
What was it?
take classes.
Squirrels take the cookies, or I don't remember what it was.
It was
but
ants steal the
ants
cookies.
steal the cookies, whatever.
That's not the one they used. We can't say that on the video.
Okay, well, yeah, we won't repeat the other one. But the tangent function repeats itself every time you go halfway around the circle. You get a positive tangent in the first quadrant, halfway around the circle you get a positive tangent again.
Got it.
That's only pi halfway around the circle. So
So do we still have to do the pi over b thing?
we're going to have to stretch or shrink it, but
Okay.
instead of 2 pi over b,
We're going to have 1 pi over
we're going to have 1 pi over b. So in a tangent function, if we wrote tangent of bx, the period is going to be pi divided by b.
Okay.
Sine and cosine took 2 pi to get all the way around. Tangent only takes pi before it starts to repeat itself. So same
Okay.
idea, different formula.
Got it.
Amplitude. Amplitude is half the distance between the highest and the lowest points. But because of these asymptotes, these graphs go up and down forever, so there is no amplitude.
There's no high and no low.
There's no high and no low. But we're still going to stretch and shrink a tangent function vertically.
And that's why we need the extra blue dots.
That's why we need these extra dots here and here.
Okay.
They're only one high, just like sine and cosine were.
Okay.
So if we stretch them, when we write y equals a tangent of bx,
So
this a
whatever-
value is going to vertically stretch, or if a was smaller than 1, shrink
Okay,
our tangent function.
okay.
So the vertical asymptotes again are going to be at x equals plus or minus pi over 2.
Why is it x equals?
X equals is the equation of a vertical line.
Oh, vertical line.
Every
x
time
equals.
we had lines that were vertical asymptotes, we wrote them. Well, those that got full credit wrote them as x equals 2 or 3 or whatever it was.
Got
but
it.
always wrote it as x equals.
Okay,
Okay, here we go. We're going to review just the concept of our translations. We have our equations from last class. We spent some time with this, and hopefully you still remember what some of these things mean. But just to review, the amplitude of these functions is the a value, or the absolute value of that. The period for sine and cosine is 2 pi divided by b. And the phase shift is just our left and right motion of our trig functions. In this case, both of them say x minus c, so we're going to go right c. And it'd be left c if we had x plus c inside that parentheses. All right, so we'll say the phase shift is positive or negative, and that positive shift means it goes to the right, and negative shift means it goes to the left. Vertical shift is our up and down motion, and that's going to be from d, so it'll be up d, unless it was minus d, and then we'd
Then
go
it would
down.
go down.
All right?
the second equation we have here is the cosine. That's going to work exactly like the sine. We didn't list tangent for you, but tangent's the same except for
The amplitude and the period. The amplitude doesn't exist in a tangent function. We have a vertical stretch. Same answer of A takes care of that. And the period of tangent is pi divided by b instead of 2 pi.
very good. And of course, tangent has asymptotes. All right, so what we're going to do is we're going to list our things we know, our amplitude and our period. We're also going to talk about our phase shift and vertical shift, and then we're going to create a graph, and we're going to do that on graph paper. That's important.
Do we have to use graph paper?
We have to use graph paper. Very messy trying to figure out where the dots went. Okay,
All right.
so the amplitude would be
4.
But what
But it's a
about-
negative, so we're going to flip it over.
very good. Okay, and how about the period?
The period of a sine function is 2 pi divided by 1 in this case, so just 2 pi.
Okay, doke. So what we need to do is we need to draw a sine curve. We are on sine, right? Yep, draw a sine curve. It's been flipped over. It's got an amplitude of 4. 4 is not going to fit on my graph. So the first thing I'm going to do is I'm going to make each of these halvesies. Sure, that's a real word. And be able to count up and down 1 unit that way. My period's at 2 pi, so my first mark will be at 2 pi. Chop that in half. Pi. Chop that in half.
And you notice she went to 4 little marks, so she could chop it in half twice. That'll be helpful.
That'll be very helpful. You always want 4 little pieces. You can also think of 4 quadrants on the unit circle. It's the same thing. Okay, so we're going to start with a sine curve which starts at
0, 0.
0, 0. And then we go down to 4, back to 0, up to 4, and back. Okay,
Yes.
now, this is called the modified parent. It's a parent that was stretched, but it's not the actual answer, because the actual answer involves
Moving.
this plus 2.
We're just going to move that graph then up 2 spaces.
Yes, we are. So this wording, phase shift is always left and right. Is there a phase shift?
No phase shift.
No phase shift. You can say 0 or none. Is there a vertical shift?
Yes.
Thanks. What
Up
is
2.
it? Okay. So we're going to take this graph and we're going to move all the dots up 2. Oh, 2 is that many. I lost track of my own scale there for a second.
Yeah, don't do that. It'll look funny. And next time you have a dinner party and you're graphing sine functions, people will look at you funny.
People look at me funny anyway. All right, so there's our sign. So the reason, again, that we're using graph paper is because we have to take those dots and slide them up to or wherever we need to go. Okay, make sure you label your scale there. Oops, which means I should put A
You should put a scale on your axis, your y-axis,
There we
not
go.
your x-axis.
on my y-axis. Okay, next question. We're going to do the same thing here. What is our amplitude?
Amplitude is 1.
Yes, it is. What is our period?
Period is 2 pi, because there's no number in front of x, so it's 2 pi over
Okay,
1.
but wait, there's a number with x.
That just moves it left pi over 2.
Okay, notice this is being plussed. That plussed, added.
Plus is a good word.
So that's not a stretch or shrink, that's a slide. We'll get to that in a second. So I'm going to start off just drawing a basic cosine curve. Okay?
So you're going to use the amplitude and the period and draw like a modified parent function every time?
Every time. You always start by graphing these two first and do it dashed. Okay? So I'm going to count by ones this way.
And that's just what we did last time, isn't it?
It's exactly what we did last time. 1, 2, 3, 4. There's my 2 pi. Cut it in half. Pi. Pi over 2. Okay, that's really meant to be right there. And 3 pi over 2.
Just blame the board.
Yeah, but that one was me. Okay, so here's my 5 dots. Cosine starts at 1. And we have our modified parent, we call it. Okay? All we're going to do to this is now we're going to go back and identify. I messed up my color coding. You know how badly that bothers me? Okay.
It only bothers you.
It only bothers me. Phase shift. I see x plus pi over 2, which means we're going to go to the
left
or negative
pi over 2.
I see a vertical shift on the end. I see a plus 1. So that's going to go
up 1.
Up 1. Every dot needs to go left pi over 2. First thing you want to think about is how many tick marks is this?
Well, on our scale, pi over 2 is 1 box.
1 box, 1 tick mark. So everything's going to go left 1 box. And how many tick marks is this?
Up 1 box.
So we got 1 box and 1 box, 1 tick and 1 tick. Okay, every dot. Left 1, up 1. Left 1, up 1. Oh, look, those two touched. Left 1, up 1. So do those. Left 2, up 1. And left 2, up 1. Ta-da! Okay. Remember, this is the top of the cosine that's going to curve down again. Don't draw a line on the end.
Yeah.
No, 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 no.
It doesn't keep going.
It does not keep going. Okay. All right. Easy?
Easy.
Okay, Mr. Lecky.
Oh,
this
sure.
one looks harder. You get the hard one.
I get the hard one?
Yep.
What did I do wrong?
Nothing.
All right, we'll start off with our amplitude or period again. So what's the amplitude?
Amplitude is 1.
1, because there's a 1 there.
Yes, there is.
What is the period?
The period is 2 pi. No, it's 2 pi over b, so it's 2 pi over 3.
2 pi over 3, and if you remember anything from last class, this is already factored out. That's a good thing for us. We'll talk about later examples when it's not factored. All right,
Okay.
so we've got our period is 2 pi over 3, and our amplitude is 1, and we're going to graph a sine function. So let's go here, and we want to go 2 pi over 3. So 1, 2, 3, 4 marks. What's half of 2 pi over 3?
Half of 2 pi over 3 would be 1 pi over 3.
Yeah, that's half of 2, isn't it?
It
All right.
is.
What's half of pi over 3?
Half of a third is a 6, so it's pi over 6.
If that's 1, 6, 2, 6, 3
3,
pi over
6.
6 is really what?
Pi over 2. Now, if they forget to reduce that, are we going to be mad?
No, I'm just going to look at them funny.
Okay,
But it'd be nice if they reduced their fractions.
it would.
All right, let's go with the amplitude here. We don't really need that anymore.
Oh, but you need the other part.
Well, we just rewrite it. Okay. So now we got our scale going on the vertical axis. Our amplitude's only 1, so we'll just go ahead and keep it at a 1, 2, and a 3. Is that okay?
Sounds good.
All right.
It's a sine curve, so how about if we start at the origin?
Start at the origin. 0, 0. And then we're going up 1.
Yep.
0, down 1, back to 0 again. Yes?
Yes. And this is the modified parent, right?
Yes.
Okay, so that's not our answer.
Basically, that's our amplitude and our period only.
Okay.
Now we're going to talk about our phase shift and our vertical shift. You're using PS for phase shift?
I am.
I'll adopt the notation. Vertical shift. What's the phase shift?
Phase shift. Well, I see x plus pi over 3, so it must be minus pi over 3 or left pi over 3?
Minus pi over 3 or left if you don't want to write the minus sign. So we got to go left pi over 3. But on this graph, how far is pi over 3?
Well, it looks like pi over 3 is 2 boxes.
2 of them. So we're going to go left 2. You called them tick marks.
I did. We should probably call them boxes, though. I like boxes better.
Boxes.
I'm a woman. I change my mind a lot.
Well, no comment. Okay.
Vertical shift.
Vertical shift. Well, there's nothing else over here.
So plus 0?
We're not moving at all.
Okay.
Okay, so literally, if we wanted to, we could take our graph, our original graph, and just move it left 2 boxes.
Yes.
So here's my original one from that, or that modified parent. Can I just move it left 2 boxes?
Yes.
And I end up with that function right there.
Yes.
Which would have actual points here, 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 and here. And if you were to continue your scale, this would be negative pi over 6 and negative pi over 3. And we're done.
Okay. So it's not always 1 box. Sometimes it's 2 boxes.
Nope, we got to go according to your scale.
Okay.
And we'll work on in class what happens when we get weird scales. But we're going to save those for class. All right, tangent. Tangent function, does it work any different?
The period's different.
Period's different. What's the amplitude of a tangent function?
There is no amplitude. The A value is 1.
So no amplitude. But the one number in front of that is 1, so there's no vertical
shift. Stretch.
Stretch at all. And you don't have to write that down. We're going to write it down so you know we covered it, but you should just recognize that. Okay, so the period of a tangent function is normally what?
Pi over b.
Pi over b. And b in this case is?
1/4.
1/4. So it's pi divided by a fourth, which is really just
4 pi.
4 pi.
So it's a stretch.
So we're horizontally stretching this to be, well, 4 times longer than it normally is. Okay, let's graph that modified parent function.
Okay.
All right, is that okay?
Sure.
So we're going to take our axis, and where do our asymptotes on a tangent function go?
Well, they're at half the period, so they're at 2 pi.
They're at 2 pi. So we're going to be 2 pi here and negative 2 pi here, and notice that's 4 spaces in between.
Yes.
Okay? which means half of that is going to be pi, and this half will be negative pi, and we have vertical asymptotes of our parent function here and here. And tangent started where in the middle?
At 0.
At 0, and then went up to 1 and negative 1 because there was no vertical stretch. So our function for tangent looked kind of like that.
Yes.
All right. It's a little harder to move the tangent function with all those asymptotes and dotted lines, but
Especially sliding it left to right is challenging. Again, we'll practice that in class.
whatever you got to do to make it easier to figure out, that's what you do. All right? What's this minus 5 do to this function?
That's outside, so that's a vertical shift.
So it's a vertical shift. So is there any phase shift?
No sliding left and right.
No phase shift, but a vertical shift was equal to
Negative 5.
negative 5 or down 5. Is that okay?
Correct.
So what happens when you move a vertical asymptote down 5 spaces?
Well, vertical lines go up and down forever,
So-
so it's still there.
So it's still there. Now we just have to move these 3 original points down 5 spaces. So our
Okay.
first point was here. If we move it down 5 spaces, that's 1, 2, 3, 4, 5. I
We
should
might need
probably
some more
get some
tick
tick
marks.
marks down here.
More boxes.
Good job counting the boxes before we graphed it, huh?
No worries.
All right.
That's what they're gonna do, so.
Yeah. The next one was here. And we're going to go 1, 2, 3, 4, 5.
Yes.
Looks good enough to me. The last one was at pi comma 1. And it's going to go down 1, 2, 3, 4, 5. And then we just draw our tangent function between our asymptotes, just like we've been doing before.
That's not so bad.
Piece of cake.
Okay, your turn, next question.
Next one. Why is this one not like the rest of them?
Well, it says there's a big hint there that the phase shift is not pi over 2.
See this? We don't write that because we're bored.
Okay, that's the whole reason we took an extra class before we learned this lesson, right?
Yep. Sure remember what we did last time? We had this 2x plus pi over 2. Whenever we have two things going on to our inside of our function, we need to separate the horizontal shift or stretch. Or
The B and
sorry,
C.
We have to separate the B and C.
There we
you.
go.
That's so much easier. Okay, so we're going to rewrite this first before we get started. In rewriting just the inside, notice we're not going to change anything on the outside, but we're going to factor out this 2.
Okay.
So what are we left with? If we take 2 away from 2x, we're left with an x.
Yes.
But what happens when you divide pi over 2 by that 2?
I'm not so good at that, but I know that 2 times something has to make pi over 2.
Okay, so 2 times what makes pi over 2?
Well, 2 times pi over 4?
How about pi over 4?
Is there an easier way?
Yeah, there is. We'll talk about that in class.
Great.
Little hint, you could set that equal to 0 and solve, but we'll get to there later, okay, in case you're listening.
Could you divide if you wanted to divide?
You could.
Okay.
Basically, 2x turned into x by dividing by 2, so you're going to basically do pi over 2 divided by 2, which is pi over 2 times a half,
Gotcha.
which is pi over 4. So there's lots of ways to get here, but you just need to make sure you get the right number out of that, because we said before the phase shift is not pi over 2. What's our phase shift according to that?
Left pi over 4.
Left pi over 4. Get off your phone. All right, here we go.
My butt was vibrating. You
So
asked.
here we go. We're going to start just like we did before. Once we've rewritten it, it's the same problem as we had the last, 4 examples?
4 examples. Okay,
So-
amplitude's 3.
Amplitude is 3, and the period is
2 pi over 2.
2 pi over 2, which is simply
Pi.
pi. And then we're going to run over here. We're going to go, okay, I need an amplitude of 3. 1, 2, 3, 1, 2, 3. What is my period? It's pi,
Pi.
so 1, 2, 3, 4, that's pi. Half of that is pi over 2. Half of that is pi over 4.
3 pi over 4.
Yay! Our original points for a sine function will be at 0, 0. Pi over 4 is going to get up to 3. That's why I put it up there. Here, here, and here. There's our quickly done amplitude and period.
Beautiful.
Now what are we going to do to it?
Phase shift.
Phase shift.
We're going to go left pi over 4.
Phase shift is left pi over 4, or we write that as minus pi over 4.
And we don't care if you write left or minus.
Left or minus is the same thing.
Okay.
Vertical shift,
Up 1.
up 1. Okay, so I've got to take all of these points, and I've got to move them left pi over 4, which in this scale, pi over 4 is 1 box.
Okay, so left 1 box.
Left 1 box,
Up
and
1 box.
up 1 box.
Okay.
All right, so I'm probably going to need another tick mark up there.
Good thinking.
All right, so let's see if we can do this in, how about green? Here were my original points. I need to move all of them left 1 box. I didn't get them all.
You didn't.
And up 1 box. Left 1, up 1, left 1, up 1, left 1, up 1. That's left pi over 4, up 1. So our new graph simply looks like that.
Beautiful.
And that's one period of our sine function. Can we keep going?
We could keep going. We could draw as much as we want.
Yeah, but we're bored already, so let's keep
Yeah.
going.
Okay, next question.
All right, your turn.
Backwards.
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 Should I have walked backwards?
Here's your answers in case
Thank
I need
you.
help. Okay, backwards.
That's
What
right.
if I give you the information and I need the equation? So we've done this before. We did this last class. The only difference is now we have A, B, C, and D to account for. All right, next example. We're going to write two equations of the cosine function. So remember our cosine was y equals A cosine B x minus the C, that's our phase shift, and plus the D. So we just need to account for all four of these variables. Okay? A comes from the
Amplitude.
amplitude, which is 2. So A is 2.
A is 2. Now we're going to make it plus or minus 2 so we can get two equations out of it. How's that?
That sounds great. Okay, B comes from the
Period.
period. So if the period is 6 pi, we set that equal to,
2 pi over b.
right?
And we stare at it until we find an answer.
We get a third.
Oh,
If you need
okay.
help with fractions, come see us, because really, you're in pre-calc.
And we're good at fractions.
We like fractions. Well, let's not go that far. Okay, phase shift is 2 pi over 3. Since this is a positive 2 pi over 3, there's no negative written there, then that's just your C number, 2 pi over 3. And the vertical shift then would be,
Negative 5. D is minus 5.
so this is D. And all we got to do is plug in our stuff. They're
That's
not
it?
pretty colors, but yeah, the hardest part about this is finding the period, or rather using the period to find the B value.
That's so simple, no one should miss it.
Okay, I should stop talking because I can't focus on what number goes where. A
1/3.
was plus or minus 2. B is 1/3.
Parentheses.
X minus.
2 pi over 3. Your head's in the way.
I'm sorry. Move your body. Okay, and then plus.
How about minus?
Okay. Just because you asked nicely. You forgot please.
Please?
Okay.
Minus?
Minus
5.
5. Ta-da!
So we have to make sure that 1/3 is factored out of there.
Yes.
But we don't have to do anything with it?
Nope.
We can leave it that way?
We can leave it that way.
That's easy.
I'm okay with that.
All right.
If you feel like distributing it, go right ahead.
No
but
way.
really,
Leave-
why
leave it,
do more
please.
work than you have to? Okay, example 3. We are going to write the equation with the given graph, and we're going to use the picture instead of being given all this stuff. So the first thing we need to start with is all the stuff. Okay?
So what stuff do we get first?
So, well, when we are whether it's a sine or a cosine, we need to start with amplitude. That's the amplitude is the best place to start. So, literal definition of amplitude was,
The half the distance between the highest and lowest point.
so pick a low point, pick a high point. That would be how many? From a 2 to a 6?
4.
4. So half of 4,
2.
2. So all I'm going to do is I'm going to count up from my bottom, down from the top, and I'm going to draw in this little what I call midline. That's the middle. That used to be the x-axis. So now I can quickly see that up from there would be,
2.
and the amplitude is,
2.
which means the A value is
2.
Okay.
2.
Got it, that is 2.
Oh, sorry.
Okay,
we're
now
done.
I'm going to go out of order. I'm not doing, we're still thinking of this equation. Okay? This is still our parent equation that we're thinking of here. Same one we used last time. The problem is, I'm not going to do them in the A, B, C, D order. This order is going to make a lot more sense, so just trust me, okay? So we've got that the amplitude was 2. Not only was this the old x-axis, and that tells me that from here up to there was 2, but it also tells me that from there up to there is 4, which means that the vertical shift, I know it's out of order, is 4, which means the D is 4.
So really all you're doing is finding out how much the y's changed.
I'm doing everything up and down first.
Vertical first.
Vertical first.
I can
Okay.
handle that.
Now that we've got the vertical set up and we've got this pretend x-axis in here, we need to find a pretend y-axis, and we need to find a period, okay? So let's go with period next.
Period is the time it takes for it to start to repeat itself.
Okay, so you can pick any dot you want and find where that dot hits on the cycle again.
Any of them?
Any of them. So I'm going to start here. How long does it take for me to get back down there again?
Stop!
Stop! Right there. From 0 to
8 pi.
8 pi, so my
You know,
period.
if you start at 0, it's easier to find the period.
It is. If you cannot start at 0, then find another dot that's like on a hash mark somewhere.
Yeah.
That's,
Unlike the board that can't find them.
yeah.
Graph
There's the
paper
undo
lines.
button. Okay. If the period's 8 pi, what's B?
B was going to be whatever you divide 2 pi by to get 8 pi.
In other words?
How about 1/4?
1/4 sounds fabulous. Once again, if you need fraction help, come see us. Okay, now notice that the question asks for the sine function and the cosine function. None of this information changes for sine and cosine. It's all the same for both of them. The only thing that changes between a sine and a cosine is where we look at this curve. Okay, it looks like a cosine right now, but can I get rid of that?
Yeah, just highlight it.
If we were to start in a different place, like, I don't know, on the x-axis, when in doubt, make the dot bigger.
Yeah,
Okay.
big dot theorem.
Big dot.
If you miss the dot, make it bigger.
And we think about these 5 points being my sine curve. Now it looks like a sine curve. So where is the blue sine curve in relation to where it was supposed to be from the y-axis?
It moved 2 pi spaces to the right.
It did move 2 pi spaces to the right. It also moved up, but we already got that figured out. Okay? So if we're talking about the sine function, we're going to let c be 2 pi to the right. So now we're ready to write our equation. Y equals, what is the amplitude, the a value?
2.
You like that one. Sine, what was the b value?
1/4.
Okay. X minus?
2 pi.
X minus the 2 pi plus,
4.
and that's it.
That's a piece of cake, too.
Now, if you wanted to get really fancy, instead of going to the left 2 pi, you could have come over here and slid to the right that far.
Ooh.
Okay, so there's going to be a couple of choices here. We usually, wrong thing, I told you. We usually just say, go to whatever's easy. Okay? All right.
I try to stay as close to the axes as possible.
The y-axis.
Either one of them.
Yep. Okay, so now cosine. We had cosine drawn up here a second ago. Cosine looked kind of like this. It didn't really slide, did it?
No, but it kind of flipped over.
Okay, so we
You're
can
going
either
that
do a
route.
cosine with a flipped amplitude, or what if we don't like flipping things over? That's just confusing for my brain.
Well, we could just go sideways, left or right, until we find a starting point that's at the top of a curve.
Exactly. So, again, let me get rid of that guy. I could flip him over. Where's my flip? Look at me, fancy.
Yay.
Okay, so there's a real cosine, and we're going to move him left or right until he matches. So we could go
Does
to
it
the
matter if
right
you go left
that
or
far.
right?
Not at all, and especially in this case because it's going to be the same. I'm messing things up.
You're fine.
Okay. Is that
Which
good?
one are you going to do, left or right?
Let's go to the right this time. Woo, a little too far past. I get fun with the sliding. Okay, right how far? How far did we go?
Well, that was our starting point, we went right 4 pi.
We went right 4 pi. So our phase shift could be?
4 pi.
4
So
pi.
C is 4 pi. And you said earlier A, B, and D, the amplitude, the vertical shift, and the period don't change
They
from
do
sine to
not
cosine?
change from sine to cosine. So now we're ready to write our answer.
Piece of cake here.
Okay, so we got y equals.
So does it look just like the last one?
Except for it says cosine in the middle.
Well, that's helpful.
X minus
4 pi this
4
time.
pi this time. It's going to slide further. Plus 4.
So are these the only 2 answers that work?
No, there's a bunch of answers that work. Remember, these are periodic functions, so they keep going?
The same, they keep repeating themselves.
Yes, they
I'm
do.
glad
They
you're in
keep
front of the camera right now.
repeating themselves. So there's actually a whole bunch of places you could stop along that graph. What we want to do is have a phase shift that's smaller than the period. Because if you go further than the period, then you missed one somewhere. Okay, so it's a little easier if you pick something smaller than the period.
I think that'll do it.
I think that'll do it.
You're
I
going
don't know
the
why
wrong
I'm
way.
going the wrong way.
You're
but
living in reverse.
we're done. So
We're
come
done.
say goodbye.
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 See ya.